Another feature that we're going to look at when we look at molecules is the electrons involved in a multiple bond. When you have a double bond, you have two pair of electrons, or a total of 4 electrons being shared. So in the image here, we have CO2, and you have one pair of electrons. So this would be an electron, and this would be an electron. And then you'd have another set around them. So if you think of them as overlapping, in a double bond, you really have 4 orbitals being shared. So you need to be able to differentiate which orbital you're overlapping. And what they do in dealing with multiple bonds is they call them either sigma or pi. And sigma symbol looks like that, and pi, well, you know that, okay? So anytime that you have a multiple bond, the first layer or first set of electrons is going to be labeled sigma, and the second or third, if you have a triple, layers are going to be called pi bonds. So in our carbon dioxide up here, in this bond side that we haven't labeled yet, we'll call that one sigma, and then this one we would call pi. So if you go back and look at CO2 in its original drawing that was on the picture here, a typical question would be to ask you how many sigma and how many pi in this particular molecule. And if you count them, we have one sigma here, and we have one sigma there, and we have one pi on the left and one pi on the right. So the answer would be 2 sigma and 2 pi. So at first glance, this molecule looks kind of evil. And a question would be, how many sigma and how many pi bonds? Okay, so let's count it out together. If we take, and we're going to mentally check mark or mark them somehow that we know that we've counted them. This is a sigma, this is a sigma, this is a sigma, here's a sigma, here's a sigma, here's a sigma. So every time you see a single bond, it's a sigma. When you see a multiple bond, the first one is the sigma, and then the second one is the pi. So when we're counting, I see 1 pi, and I see 1, 2, 3, 4, 5, 6, 7 sigma. So in this particular molecule, I'm sorry, I did not label my pi very well. So it's 1 pi and 7 sigma. The answer to the question would be 7 sigma bonds and 1 pi bond in this particular molecule. So here's your homework problem, but we're going to have to do a little bit of work before I can set you loose. My question for you is going to be how many sigma bonds and then how many pi bonds. Before I can set you loose, we're going to need to fix this up and make sure it's a complete and a molecule that has all the octets completed and that you know how to read it correctly. So anytime you see an oxygen and it doesn't have 4 things connected to it, bonds or whatnot, you're going to need to fill it in with lone pairs. Oxygen typically has 2 lone pairs, so we're going to add oxygen's lone pairs here. Nitrogen also is in a similar boat. Nitrogen likes to form 3 bonds, so the fourth would be a lone pair of electrons. So we will go ahead and draw in these lone pairs here. Now, whenever they draw a condensed structure in this manner with lines, they are going to assume that you recognize that there is a carbon at each one of these intersections. And that's not a big deal when we're counting sigma and pi, but it could be a big deal when you're trying to figure out what all is in the molecule. 2 more things. So anytime that you see a carbon and it does not have 4 attachments, the remaining attachment will be a hydrogen. So 1, 2, 3, 4, 1, 2, 3, 4. I've got all these carbons covered. CH3 or H3C, as it's shown on the left, is just a condensed way to say that they have 3 hydrogens attached to each one of these carbons. So if you want to draw them out, you can, but you need to recognize that there are 3 bonds attached to each hydrogen. So now you can take this molecule and you can count the number of sigma and pi and upload that into Schoology.